happy to report that has been difficult in the past, and I feel like we are prepared to be very good at this. The only thing that we need to understand is how this relates to the idea of batteries and what we've learned related to voltaic cells. So quantitative electrolysis is wanting us to talk about how much electricity has traveled through a specific solution, or a specific, like there's a specific amount of energy that's traveled in the form of electricity. And we now just need to say, okay, well, if that much electricity has traveled, how much of the chemical is it going to make in the battery? So for instance, let's just skip all the way ahead here, okay? And don't worry about this here, what I've got highlighted. If we remember how a battery is made, the zinc falls apart as the electricity travels, and the copper is made as the electricity travels. And so the idea is we can make a certain amount of copper, and if we have how much electricity has traveled through the wire, we know how much copper we can make. That's what the idea of quantitative electrolysis is. So you can use dimensional analysis, converting from one thing to another. And we're going to convert from electricity to grams of our substance. We have had practice with the train tracks so many times already, and you're going to have to use a mole ratio, but don't be afraid. If you want to better understand this, I would suggest go and watch a video. Khan Academy has a good video about this, but I'm going to show you an example of how to do it, just in case you're struggling and you're like, this doesn't make a whole lot of sense to me. Maybe pause the video here to kind of try to wrap your head around it. If you're like, nope, I don't got that. Come with me on this next adventure. Okay. Oh, I forgot I linked it. Oh, that was
No matter which approach we take. Let's say we have a beaker of distilled water at 25 degrees Celsius, and to the beaker we add some barium sulfate. Barium sulfate is a white solid. A small amount of the barium sulfate dissolves.
All right, team. That was awkward. I need to make sure. Oh, there we go. Okay, so we're past it. We're on to the next slide. So if you want to watch this, you can click on that slide. It'll take you right there. How can I go from current and time to grams? How do I do that? A constant current of 2 amps is passed through a solution of copper sulfate for 965 seconds. What mass of copper is produced? Do it to 3 sig figs. Now, before we look at all this, let's go ahead and let's take a look. So I've got my copper sulfate solution is right here. So as the electricity flows, it's going to cause the copper to be formed. We know that because we've learned about batteries. And if we can look here, this is the half reaction for it. We are taking from the copper sulfate solution Cu2 plus, adding 2 electrons, and we make solid copper. 2 moles of electrons make 1 mole of solid copper. That's the reaction. That's the balanced reaction. That's how it works. So let's go back. Let's go back to here. Step 1, we need to find out what is our charge. And so we go current times time is equal to 1,930 coulombs. We put those coulombs on the beginning of our train tracks. Okay? How many moles of electrons, N, need to react in this reaction? So Cu2 minus is that whole process that we saw on the next slide is 2 moles of electrons. And that's per reaction. Every reaction, there's 2 moles of electrons that are used. And so if you don't understand that, you can go to the next slide and see that. We already talked about it, but let's go back. All right, so the train tracks, right here, dimensional analysis, I lay it out. This is how it's laid out. 1,930 coulombs times 1 mole of electrons divided by Faraday's constant. That's going to be able to help us convert from coulombs to moles of electrons, which is what they're telling us to do right here. That's the very first step. Faraday's constant goes right there. Okay, so I'm converting from coulombs to moles of electrons. Now, and that's how many coulombs are in 1 mole of electrons. That's how I got that value. Again, Faraday's constant. The next one is I go with 1 mole of, let me set this up. My mole ratio for electrons to moles of pure copper is 2 moles of electrons. Every 2 moles of electrons, I can make 1 mole of copper. And now I use my molar mass of copper to convert that to grams. It is that simple. And once you do this once or twice, you're like, oh, I've got it. I strongly suggest practicing this a few times. I wish you success. Team, you've got this.